So to understand how complements are going to help us here, let's go ahead and look at an example. Now, in mid-2018, a poll by Gallup found that 36.8% of the citizens in allied nations approved of U.S. leadership. Now, I can write this by saying the probability someone approved was 36.8%, or 0.368 as a decimal. Now, let's say I wanted to find the probability of the complement. That is, if I have approved, the only other option is that they did not approve. So I have approved versus its complement. I'm going to go ahead and write an A up here and an AC here to represent complement. Now, if 36.8% approved, I need to find the percent that don't approve. I know in total there are 100% of people, right? And so if I take the 100 and I subtract off the 36.8% that approved, I'll be left with the percentage who didn't approve. And that in this case, I believe, is 63.2%. That is, if I take the full 100%, subtract off those who approved, I'll get those who do not approve. This gives us our first formula here. And that is, in general, if I take 100% minus the percentage of one, I get the percentage of the other. I'm going to write this as a decimal instead. So I know 100% is 1 as a decimal. And if I take 1 minus the probability of A, I get the probability of the complement. So once again, if I take 1 minus 0.368, I'd get 0.632 out. So this is our first little formula here. And it tells us once again that if I want the probability of the complement, I take 1 minus the probability of the original, and it'll give me the complement out.